Hi folks, in this particular video we will be gonna discuss about uh, data science interview question day 4. Hi folks, it depends upon companies to companies. Maybe if the company is startup, they will gonna give you an assignment. They will be gonna check your understanding how you can approach that particular problem and how you can solve it. Okay, so let's get dive into it. So, question number one of our day 4 series of data science interview preparations. Okay, so now we'll get started into with the question number one. It is upsampling and downsampling, and with examples. Okay, all right. So let's get dive into it. So we'll just try to understand how you can represent to the interviewer that you have to understand. Okay, like classification data set with the skewed class proportion is called an imbalanced data set. The classes makes up a larger proportion of data sets are called uh, majority classes. Those make up the small proportions are like minority classes. Degree of imbalance proportion of minority classes: mild 20 to 40% of the data set, moderate 1 to 20% of the data set, extreme less than 1% of the data set. If we have a balanced data set, okay, so first try training on the true distribution. If the model works well, generalize, you are done. If not, try to upsampling and downsampling technique. So upsampling technique what says that upsampling is a process of randomly duplicating the observation from the minority classes to reinforce its signal. First, we resample the module from scikit-learn module for resampling the Python. We have a scikit-learn.utils import resample. Next, we create a data frame and upsample the minority classes. Here are the steps basically. First, we will separate the observation from each class in different data frames. Next, we will resample the minority classes with replacement, setting the number of samples to match that of majority classes. Finally, we will combine that upsampled minority classes, the data frame with the majority data frame with the original majority class data frame. So number two, there is a downsampling. Okay, so downsampling involves randomly removing the observation from the majority classes to prevent its signal from dominating the learning algorithm. So process is similar to the that of a sampling, but first we separate the observation from each classes in different data frames. Next, we will resample the majority classes without replacement, setting the number of samples that match that of minority classes. Finally, we will combine that downsample majority classes data frame with the original minority class data frame. Then, the question is like, what is a statistical test data validation with an example: chi-square, ANOVA test, z-statistics, t-statics, f-statics, and hypothesis testing. Okay, before discussing the different statistical tests, we need to get a clear understanding of what a null hypothesis is. Okay, so first we need to understand about null hypothesis. Null hypothesis proposes that has no significant difference exist in the set of given observation, and two samples means are equal, alternate two sample means are not equal. For rejecting the null hypothesis, a test is calculated. Then the test statistics is compared to the critical value, and if found greater than critical value, the hypothesis will be rejected. Then other concept of critical value, that is like if the point is beyond the reject, then we will reject the null hypothesis. Critical value tells us that what is the probability of n number of samples belonging to the same distribution. Higher the critical value, which means the lower the probability of n number of samples belonging to the same distribution. The critical values can be used to do the hypothesis testing in the following way. You will calculate the test statistic. You will calculate the critical values based on significance level alpha. Then you will compare the test statistics with the critical values. So important point is like if test statistic is lower than the critical value, you will accept the hypothesis or else reject the hypothesis. Chi-square test. What is a chi-square test? Chi-square test is used if there is a relationship between two categorical variables. Okay, so chi-square test is test used to determine whether there is a significant difference between the expected frequency and observed frequency in one or more categories. So chi-square is also called as non-parametric test, and it will not use any parameter. Okay, the second is ANOVA test. ANOVA is the like analysis of variance, which is used to compare multiple three or more samples with a single test. Okay, so useful when there are more than three population. ANOVA compares the variance within and between the groups of population. If the variance is much larger than variation, this means that the different samples will not equal if the between and within the variance are approximately sample size. So then there will be no significant difference between the sample means. So assumption of ANOVA, all all population involved follow normal distribution. All population have the same variance. The samples are randomly selected independent of one another. ANOVA uses the mean of samples or population to reject or support the null hypothesis, hence it is called as parametric testing. Okay, z-test is also there, like it is assumed to be a normal distributed. The z-score is calculate the population parameter as population mean and population standard deviation, and it is to validate the hypothesis that the sample drawn belongs to the same population. The statistics is used for this hypothesis testing. It's called z-statistic. Z-statistic, the score from which is calculated as z, which is equal to x minus mu by sigma by root n, where x is a sample, mean mu is equal to population mean sigma by root n, which is equal to the population standard deviation. If test statistic is lower than the critical value, then we will accept the hypothesis or else reject the hypothesis. And t-static is used to compare the mean of given samples like c-test, t-test, and also assume the normal distribution of the samples. T-test is used when the population parameters are known. There are three versions of t-test. Independent sample t-test, which compares means for two groups. Paired sample t-test, mm, which compares the mean from same group at different times. Sample t-test is test the mean of single group against the known mean. The statistics for hypothesis testing is t-statistic. X1 is mean of a sample A, X2 is the mean of a sample B, N1 size of a sample 1, N2 size of a sample 2. Okay, so in the next video we will be going to understand what is a central limit theorem. Hi folks, my name is Akash. Today in this particular video, we will be going to start where we left. Okay, all right. So what is the central limit theorem? We're going to uh, continue that part in this particular video. Okay, so we were left there. Okay, due to some technical glitch, technical kind of a things, I was not able to record the video, so I'm just combining the both of the videos, so you will the like day four kind of a things will be not missing that. All right. So uh, this is a particular thing we'll be going to dive into the thing sort of stuff here. All right. So central limit theorem. This theorem states that the size of sample increases the distribution of mean across multiple samples will approximate a Gaussian distribution. Gaussian distribution nothing but it is a normal distribution. Okay. So generally sample size equal to or greater than 30. So are the considered sufficient for the CLT. CLT is nothing but central limit theorem to hold. So it means that the distribution of sample means is normally distributed. The average of the sample means is equal to the population mean. This is a key aspect of the theorem. And what's a what's a particular what's a particular assumption that central limit theorem is like data must follow the randomization condition. It must be sampled randomly. All right. So second is samples should be independent of each other. One sample should not influence the other samples. So sample size should not more than 10% of population when sampling is done with the replacement. All right. So the sample size should be sufficiently large. So the mean of the sample means is denoted like mu into the x bar, which is equal to mu, where mu x is like mean of a sample mean. Okay, mean of a sample mean. It's mean of a sample means the mean of a sample, and mu is nothing but population mean. That is a particular thing you need to understand. And standard deviation sigma x bar sigma by root n square root of n, that is a standard deviation basically. So this is a particular thing you need to understand, that one advantage of central limit theorem. So advantage of a central limit theorem is that we not worry about the actual data, since the means of always it is a normal distribution. We can create the component intervals. Okay, perform the t-test, ANOVA test from the given samples. So there will be might maybe ask the questions about what is a correlation and coefficients, right? So we'll get understanding, we'll get dive into it, and we'll just start to understand that particular thing. Correlation coefficient is a statistical measure that calculate the strength of relationship between the relative moments of two variables. All right, we use both of the strength. So correlation coefficient is a statistical measure, okay, that calculates the strength of relationship between the relative moments of two variables. We used it to measure both strength and direction of linear relationship between the two variables, and that value should range between minus 1.0 to plus 1.0. Okay, so calculate number should be greater than 1.0 and less than minus 1.0. So this means that there was an error in the correlation co-measurement. Correlation will be the negative correlated, right? Shows the perfectly negative correlation. That is only we are able to say when the correlation is minus 1.0, it is negative correlated. Okay, all right. So this is a correlation, negative correlation, where a correlation 1.0 shows that a perfect positive correlation. Understand, when we are doing r equal to zero point 0.4, it is a positive correlated. Okay, so r equal to 0, so that should be comes under 1.0. Either it should be positive correlated or negative correlated. All right, so there is a no correlation when it r equal to is equal to 0, then there is a no correlation. When there is a negative sign with the value, then it is negative correlated, folks. Okay, so correlation coefficient formulas are find how the strong relationship is between the data. Okay, So this formula returns a value between -1 and 1, where that indicates a strong relationship. Okay, so -1 indicates that there is a strong negative relationship. A result of 0 indicates that there is a no relationship at all. Okay, okay. I hope this gives you clarity. All right. So what does that mean? Correlation coefficient of 1 means for every positive increase in one variable, there is a positive increase in fixed proportion in the other. Okay, for example, shoe size goes up. Okay, almost goes up. Shoe size goes up almost perfectly correlation with the foot length. Okay, the price of the shoes will goes up when the size of the shoes is increasing, right? And correlation coefficient of -1 means for every positive increase in one variable, there is a negative decrease of fixed promotion in the other. Okay, so for example, amount of a gas in tank decreases in almost perfect correlation with the speed. Okay, so third thing you need to understand is zero means that for every increase, there is not positive or negative increase. The two just are not related. Alright. So what's a negative correlation then? Negative correlation is a relationship between the two variables in which one variable increases as other decreases and vice versa. Okay, in statistics, perfect negative correlation is represented by the value -1. Negative correlation or inverse correlation is a relationship between the two variables whereby they move in opposite direction if variable x and y have a negative correlation or negative correlated. As x increases in a value, y will decrease. So x decreases in value, y will increase. Okay, so this is a particular thing, examples of negative correlation, and positive correlation is nothing but there is a relationship between the two variables. Okay, in which both variables move in tandem. Okay, so there will be a same direction. Positive correlation exists when one variable decreases as other variable decreases. One variable increases then while the other also increases. So it is a like examples of positive correlations basically. So we use correlation coefficient to measure the strength and direction of linear relationship between the two numerical variables x and y. So correlation coefficient for sample of data is for the sample of the data is denoted by R. Okay. Then there is a Pearson correlation coefficient where it is most widely used correlation coefficient. Pearson correlation measures the linear association between the continuous variables. In other words, this coefficient quantifies the degree to which the relationship between the two variables can also described by a line. Its formula is developed by the Carl Pearson over 120 years ago is still mostly widely used today. Okay, so this formula is the correlation R is like R which is equal to uh, n of summation of xy minus summation of x multiplied by summation of y divided by root of n sigma x square minus this bracket sigma x whole square n sigma y square minus sigma y the whole square. Okay, so this is a particular thing. So what n will represent, it is a number of pairs of data as a sample means of all the x values and y values respectively, and sx and xy a sample standard deviation of x and y values. Okay, so what we will do is find the mean of x values and mean of y values. Okay, then we will find the standard deviation of x values, call it as sx, and standard deviation of y values, call it as sy. For example, to find an sx, you would use the following equation. Okay, so for each of n pairs of xy in the data set, take add up n steps from step 3. Okay, n pairs which you have taken, you have to do it here. So you have to divide the sum sx into xy. Okay, divide the results by n minus 1 the number of xy pairs, it is same as multiplying by 1 over n minus 1. So this give you the correlation now. So they might not ask this particular question, folks. So it is a theoretical question. So maybe the kind of a tweak of having asking the hard questions, that may be the case. Okay. So the fifth question they might ask is like, what is the difference between machine learning and deep learning? So machine learning is a technique to learn from that data, and then apply what has learned to make an informed decision. So the main difference between deep and machine learning is machine learning models becomes better progressively, but the model still needs some guidance. If a machine learning model return an inaccurate prediction, if a machine learning model returns an inaccurate prediction, then a programmer needs to fix the problem explicitly. But in case of a deep learning model does it by himself. Okay, so machine learning can perform well with small size data, and deep learning does not perform good with smaller data sets. Machine learning can work with some low end machines also, but deep learning involves many matrix multiplication operations which are better suited for GPUs. Okay, so features need to be identified and extracted as per the domain before pushing them to the algorithm. So deep learning algorithm try to learn high level features from the data. Okay, that is a particular thing. It is generally recommended to break the problem into a smaller chunks, solve them, then combine the result. It generally focuses on solving the problem end to end. Okay, so training time is comparatively less. Training time is comparatively more. Okay, in case of a deep learning. So results are more interpretable. Results may be more acute but less interpretable. Okay, so no use of neural networks uses in neural networks. So deep learning uses that, and machine learning do this. Okay, then it solves the comparatively less complex problem. It solves the more complex problems. So the next questions they might ask is this related to the deep learning questions, folks. What is a perceptron? How it is related to the human neurons? Okay. If we focus on the structure of biological neuron, it has a dendrites which are used to receive the inputs. These inputs are summed to the cell body, and using the axon it is passed to the next biological neuron as shown this particular thing. See, right? This is a particular thing. Right. So dendrite, these are the things they might not ask. Okay. So what you have to tell is what is a perceptron? A perceptron receives the multiple inputs that applies the various transformation and function, provides an output. Okay. A perceptron is a linear model used for binary classification. It models a neuron which has a set of inputs, each of which has a specific weight. The neuron computes some function on this weighted inputs and gives the output. Weighted inputs and gives the output. Okay. So why deep learning is better than machine learning? They might ask like why you are thinking that deep learning is better than machine learning. Okay. Though the traditional ML algorithms solve a lot of our cases, they are not useful while working with high dimensional data. Okay, when it comes more like 4D, 5D, 6D, then this traditional ML algorithms can't shoot well for that particular case. For example, in case of handwritten recognition, we have a large amount of input where we will have a different types of input associated with different types of handwriting, right? There are different types of handwriting, right? So second major challenge is to tell the computer what are the feature it should look that we will play an important role in predicting the outcome as well as achieve the better accuracy while doing so. So the number eight, they might ask Like, what kind of a problem can be solved by using the deep learning? Okay, so deep learning is a branch of machine learning, so which is used to solve the problems the way that human mimics of solving the problems. Okay, so number one is image recognition, object detection. Third is natural language processing, translation, sentence formation, text to speech, speak to text, and other kind of things like transformer, building a transformer, like a caption, some kind of a system you can build it. So this is a particular thing that deep learning can help you more in respect to that. So ninth number of questions, like list down all activation function using the mathematical expression and example, and what is an activation function. So activation function are very important for an artificial neural network to learn and make sense of something complicated, nonlinear complex complex function mappings, like between the inputs and response variable. All right. So internally, what is happening internally, you don't know about it, but you are just giving the input. You're just setting the parameters. You are giving to feeding to the system. It will train that, and it will give you the output. This is the thing you are doing actually. So introduce nonlinear properties to the network. The main purpose to convert an input signal of a node in an ANN to an output signal. Okay. So why do we need non-linearities? So that may be a question, right? So nonlinear function are those whose degree is more than one. Degree means power. Power is more than one, and they have a curvature where when we plot a nonlinear function. Now we need a neural network model to learn, right? That represent almost anything. Any arbitrary complex function you give which maps the inputs to outputs, this neural network are considered as a universal function approximation. So it means that they can compute and learn any function, it can learn any function at all. Okay, so most popular of activation functions are like sigmoid or logistic, as you have seen in logistic regression, tanh for hyperbolic tangent, ReLU for rectified linear units. So what this signified sigmoid activation function? It is an activation function for a given f of x, which is equal to 1 by 1 plus exponential to the power of minus x. Okay, so it is a range between a 0 1, that is a S shaped curve. It is easy to understand. Okay, so hyperbolic tangent f of x, which is 1 into the exponential to the power of minus 2x by 1 plus exponential to the power of e to the power of minus 2x. So it will range in between minus 2 plus 1. So that is a minus 1. Like output is ranging from minus 1 to plus 1. So here optimization is easier in this method. So hence in the practice, it is always preferred over a sigmoid function. Okay. So let's get dive into the ReLU rectified linear units. It has become more popular in the past that a couple of years. Like it was recently proved that the 6 times the improvement in the convergence from tan h function, its r of x is max of 0 comma x. So if x is less than 0, r of x equal to 0. If x is greater than equal to 0, r of x is equal to some x value. So hence we see the mathematical form of this function. We can see that it's very simple, efficient. Many times in machine learning and computer science, we notice that most simple and consistent techniques and methods are only preferred and are the best. Okay, so hence it avoids or rectifies a vanishing gradient problem. So almost all deep learning models uses the ReLU nowadays. So a detailed explanation about the gradient descent using the example and mathematical expression. So as you have seen in the case of logistic regression itself, so like gradient descent is an optimization algorithm that is used to minimize some function by iteratively moving in the direction of deepest descent, as the definitely as defined by negative of the gradient. In machine learning, we use a gradient descent to update the parameters of our model. Okay, so parameters refers to the coefficient in linear regression, weights in neural networks. Okay, so parameters will be in the linear regression, like refers to the coefficient in the linear regression, and weights in neural networks. So size of these states are like a learning rate. With a high learning rate, we can cover more ground each step. So, but we risk the overshooting the lower point since the slope of the hill is constantly changing. With very lower learning rate, we can confidently move in the direction of negative gradient. Okay, so because we are calculating it so frequently, the lower the learning rate is, the more precise. Okay, but calculating the gradient is time consuming, so it will take a very large amount of time to get a bottom. So math is like, let's run a gradient descent using the new cost function. There are two parameters in the cost function. We can control m and b, weight and the bias. So since we need to consider that the impact one has on the final prediction, we need to use the partial derivatives. We calculate the partial derivatives of this cost function, considering each parameter, and the store the results in the gradient. Okay, so math, if we wanted to talk about, it will be function of m and b, right, which is equal to 1 over n summation of yi minus mx plus b the whole square. Okay, so total the whole square will be there. So gradient can be calculated by f dash of m comma b df by dm df by db. So which is, you will be computing the same, you will be replicating here. Okay, so to solve the gradient, we iterate all our data points by using a new m and b values and compute the partial derivatives. So this new gradient tells us about the slope and the cost function at our current position. So current parameter values and direction we should move to the update and parameters. Okay, so learning rate controls the size of our update. Okay, then this is a particular thing you needed to understand. Now another question is like, what is a back propagation? All right, so back propagation is the essence of the neural net training, and this method of a fine tuning the weights of a neural net based on the error rates obtained in the previous approach. Okay, tuning of the weight allows us to reduce the error rates and make the more reliable by increasing its, by increasing its generalization. Right, so back propagation is a shorter form of a back propagation of an errors. This is a standard method of training the ANN, artificial neural network. This helps to calculate gradient of a loss function with respect to all weights in the network. All right, so this is a particular, if you wanted to look at it, back propagation, it will be something looks like this. Okay, so most prominently, what is the advantages then? Like, backpropagation is fast, simple, and easy to program. Okay, second thing is, it has no parameters to tune apart from the numbers of input. Okay, it is a flexible method. It does not require prior knowledge about the network. It is a standard method that generally works well. It does not need any specific mention of features of the function to be learned. Okay, so understand in this particular algorithm basically. Sorry for that inconvenience, folks. So back propagation main idea is, for each example in the training set, you compute the output signal. You will compute the error corresponding to the output level. Okay, so propagate the error back into the network and store the corresponding delta values for each layer. Adjust the each weight by using the error signal and input signal for each layer. Okay, so this is a like computation of backward. Basically, you do like this, and this is a computation of forward basically. So how we assign the weights in deep learning? We already know that in neural networks, weights are usually initialized randomly, and that kind of initialization takes a very significant amount of repetition to converge to least loss and reach to the ideal weight matrix. Okay, the problem is that the kind of initialization is prone to vanishing or exploding gradient problems. Okay, the general way to make utilize better ways is ReLU activation function is a deep nets. Okay, general generate the random function sample of weights with the Gaussian distribution having mean 0 and standard deviation 1, and multiply the sample of which is the square root of 2 by ni. So where ni is the number of input units for that layer. So second is like likewise you have a tanh activation function. You generate the sample of weights from Gaussian distribution having mean 0 and standard deviation 1, and number two, you will multiply the sample with square root of 1 by 1 over ni. Okay, so which is a several input units for that particular layer. Okay, so in the next video, we're going to understand, folks, like this is particular little bit tricky kind of a question they might ask for the data scientist engineer, data scientist kind of an interview or machine learning engineer. For initial kind of interviews, they can drill down if you are targeting high level of interviews like big type of companies. Then they can ask, they may ask for this type of question. So what I do is two things. What I'm doing is for this day 4 I will be doing two videos. I will be uploading two videos today. So up to 13 I have completed. So up to 12 I have completed. Tomorrow I will be going to recording this particular video, folks, for to another video that will complete whole questions, basically this day 4 kind of a thing. So this 2 days will be taken to explaining you and recording this particular video. All right, so I hope this is clear. So that's it about this video, folks. In the next video we'll be going to discuss about all about day 5. Day 4's continue.